Alright, in this video I will explain a little behind how the geometry of a beach ball works, and share my experiences in attempting to make one myself. The result was a sloppy looking but nearly indestructible beach ball. So theoretically, a beach ball is not a sphere. It is an intersection of a series of cylinders. Half as many cylinders as there are panels actually. A beach ball can have an odd number of panels as well, but that would be the slightest bit more difficult to portray. Here I show 3 cylinders of the same size, equally rotated about the center of my beach ball. The beach ball is hard to see at this point, so I run the intersect operation in my CAD software. That, well, removes everything that is not intersecting. Pretty straightforward. Now the beach ball should be much more apparent. To emphasize the point, I will repeat the operation for an 8-panel beach ball. That, of course, will require 4 cylinders, half as many as 8. Looking at this shape, it is possible to see how a series of flat panels can be wrapped around each of the cylinder sections. The more panels, the more sphere-like the ball becomes. Using the knowledge from my CAD software experiment, I was able to print out a stencil pattern on a sheet of paper and begin cutting my beach ball panels. The height of the stencil is equal to the size beach ball you wish to make, and the width is the size of the beach ball divided by half of the panel count. I am going to go ahead and show an alternate method that requires less CAD and more hand skills. To start, find the biggest sheet of paper you can. All I have is a standard letter sheet, so the result will not be terribly accurate. First, draw a line equal to the length of the beach ball size you wish to make. If you wish to make a huge beach ball, then just pick an arbitrary size that fits on your paper and is easily divisible by the panel count. I will show you how to enlarge it. Next, use a compass to make some intersecting hatch marks to either side of the line as shown. I marked them so they show up on camera. Using your hatch marks, use a ruler to draw a line through the center of the large line. This line should be made symmetric to the big one and have a length equal to your beach ball size divided by half of the panel count. In my case, the big line is a measly 3 inches, and I plan to have 6 panels. So the smaller line for me should be 1 inch. Once the small line is drawn, go ahead and connect the endpoints to form a diamond. It is unnecessary, but will visually help the next step. Next, performing the same hatch operation I did to draw the smaller line from the larger one, I will find the line perpendicular to the center of each edge of the diamond shape. The 2 intersection points of the newest 4 lines mark the center of the arcs that make up the beach ball panel. Using the compass, I then score the circular arc through the 2 sets of 3 points. For clarity, on camera, I then trace the arcs I scored with the compass. Now that the panel shape is finalized, I can cut it out. My panel is very tiny, so to enlarge it, I can suspend it using a piece of clear tape, set a lamp on the table, and adjust the distances to make a shadow the size I want. Simply hang the vinyl sheet you wish to mark in the shadow and trace. Make sure to leave a margin for the material that would be consumed in the scene. Alright, now here begins my experiment. Determining the panel shape and cutting them out was not too hard. I choose to use a chemical welding solvent to assemble my first beach ball. Just like metal welding, when you use a filler metal, this adhesive has a small percent of thermoplastic suspended in a concoction of volatile chemicals. When the volatiles do their thing and evaporate, the thermoplastic is left behind to bond the vinyl. With HH66, I have between 2 and 5 minutes until the glue sets. The manufacturer does not specify a full cure time, presumably because it is highly variable. I won't explain too much of what is going on here, as I would not recommend it. If you do try this yourself, open some windows to get a cross breeze and put on safety glasses. You don't want this stuff in your eyes or your lungs. But I started by cleaning the vinyl with alcohol and some cotton balls. I then used a circle of vinyl to bond together all 6 panels at one end of the beach ball, always applying glue to both surfaces to be bonded. I then proceed to stitch up the edges of the ball using lap seams. I stitch them in short segments and do so in circles about the ball, making sure I do not get too far ahead on any seam. The rapid action of the adhesive makes this process simple. However, the tight radius and overly thick vinyl makes numerous creases and wrinkles appear. The most difficult step was closing the top end with an additional vinyl circle. After I let it sit until fully cured, I then cut a hole in the top and glue on a valve. To give it some extra strength, I glob on a lot of extra glue along the seams and let it cure. Let's test it. I am unable to burst the ball with my hand pump as I cannot give it any more force. It stretches significantly and forms a leak near the troublesome top circle. The beach ball sure doesn't look pretty, but the 0.5 millimeter vinyl makes it almost indestructible. Hopefully you found this experiment interesting. I plan to do some repair and reinforce videos in the future, as well as a heat-welded beach ball video. Please leave your comments below and subscribe if you want to see more.